Good afternoon, everyone. Today we decided to do a pre-recorded class because most of you had issues with internet connection each time we have it live. So today we'll be doing object detection, and as usual, we have to import our packages. So from here, we import our OpenCV or CV2. So import CV2. Also, we have to import NumPy. Import NumPy as NP. The next thing we have to do is to find a path to our video file. So I shared this video file with you last week. So the path to the video file. So path path is equal to video is, so I can find it in my C drive. C drive, users, folder called Armstrong, folder OneDrive, name this. I have my video file. Okay. Folder called testing1. No folder. So now the next thing we have to do is to do video capture. That's like to initialize our capture. So create a variable called cap. Then we do video capture. So CV2 dot video capture. Then over here we pass in our video path. So read path. So this is going to capture the video. Then we have to look through each and every frame in the video, right? Because we said the video is made up of frames moving at a certain rate. So we write this command while true. We are going to do cap.read. Okay, and this function is going to read through all the frames in the video. Meanwhile, cap.read returns two outcomes. One is a boolean, and two is a frame of the image. So we'll do this. And once we have been able to capture or read the frame successfully, we want to show the frame. So we go to CV2 dot show. Then this function takes in two inputs. It takes in the name of the frame, so then the frame image. Then I'll pass the frame that I've read through it. And when I'm done, how long should the program run through the frames, right? So I'll say that if statement, so if wait key, so CV2 dot wait key, that's the delay between frames. Let's make it, let's say 0. Let's make 1. Okay, so it waits like 1 millisecond between frames, and it keeps running like that. So after the first frame, it waits only 1 millisecond, it runs, the second frame goes, right? Then a key to off it. So off key, I normally use kill to quit. Um, if this go to this, you want the model to break, to break. So if I'm running the model and I press kill, I want it to break. Then one of them, I want to release capture. So dot release, have a here, and cv2 dot destroy all windows. Yeah, want to destroy all windows. Yeah. So normally, anytime you have video part to be read in OpenCV, this is a simple approach to use. You first give it the video part, pass the video part through the video capture. Then you look through each and every single frame and ensure it, right? And you're going to give the time interval between when each frame is supposed to be showed, and that's through the wait key. Okay, so realize that if I should run this, I'm going to run this. Okay. It's running really fast, okay, very fast because it's looking between one millisecond between each frames. Okay. So if I change this delay time, if I change this delay time to 30, um, it's going to be slow. Yeah, it's going to be slow. Good. So I'll keep it at, let me say, 25. Let's see how the speed goes. Okay, this looks like a bit normal. It looks a bit normal. So I'll keep it at 25. Okay. So the next thing we want to do is to process our video file. Okay. And doing video processing or image processing, it's always best to work in a grayscale, and it allows you to manipulate the images to whatever you want to. So I'll come back here and I'll change my frame into a grayscale. So what do? I create a new variable called frame. Okay. Then over here, I'm going to do convert color, cv2 dot convert color. Okay. Then I'll pass in um, the frame that I want to change. So that's this frame that I want to change to grayscale. Then I'll do CV to the color for RBG to gray. Okay, so let's see what this does. Okay, um, when we run this, so now we have converted this frame that we have right over here into a grayscale here. Okay, so we are passing this frame into this. Let me just change the name, no? So that you don't get confused. So I'll name this one gray image. Gray image. Okay, and I'll show both of them. So I'll copy the same file. So don't forget that the frame is the original thing we are bottom. Okay, and do this. So I'll go back here and change the frame to just a colored image. Okay, so that you don't get confused. And I'll pass colored image here. Colored image here. Then over here, I'm passing colored image in here. And over here, I'll be showing the gray image. Okay, so that's the difference. So first, whatever you read is a colored image. Then I'm converting a colored image into a gray image using this function. I want to show the two. Okay. So let me go here and show it. Okay. So this is that of the gray. So now we have the gray image being shown. So we can comment this and run this and see. This is showing the colored image, right? There's a video for the colored image, and this is showing that for the gray image. Okay, but we don't need this again. It's just a gray. Okay. So that's what we need. Um, Now, why do we have to take the gray image? So as I said early on, um, most of our data manipulation will be done using the gray image. So that makes it much easier to work with. Okay. Yeah. So we move from here. Um, so the next thing we will do is to understand some metrics relation to get some foreground, some background understanding. So for example, I'll stop sharing my screen and I'll explain the concept here. So share screen, share wall. Okay, so we discussed that images are made up of array of numbers. Okay, and now you've converted our image into a grayscale. Okay, so that's like just one dimension, just having only one channel. So you're just going to have a matrix that look like this. Okay, matrix that look like this. Let me say I'll put one here. So here, make this a 3 by 3 matrix. Okay, so let's say this is frame one. Frame one is a first frame, and this frame has some numbers in there. Then like very simple numbers. Um, this is 5. Very simple numbers. This is 0. This is 1. This is 2. This is 1. This is 5. This is 7. Okay. Then the next frame, this is frame 2. It's going to be the same size. So um, you're also going to have a 3 by 3 matrix here, 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 and there. Okay. All messed up. Yeah, that works. So continue drawing. But and this is frame 2. Okay, and in frame 2, these are the values in there. Okay. This is 6. This is 2. This is, let's say, 4. This is 1. This is 6. This is 8. Okay, so these are 2 frames. Okay, so this is frame 1, frame 2. Okay, now let's find the difference between frame 1, no, frame 1 and frame 2, the difference. Okay, so I'm going to have frame 2 minus frame 1. Okay, I'm going to form a new matrix, which will also be a 3 by 3 matrix. That will be a new image. Okay, a new gray image is also a 3 by 3 matrix. So this is it. Draw this here, draw that here. Okay, so we do element wise subtraction, right? So 2 minus 2 which will be 0. 4 minus 4, which is 0. 5 minus 5, which is 0. 6 minus 0, which is 6. 2 minus 1, which is 1. 4 minus 2, which is 2. 1 minus 1, which is 0. 6 minus 5, which is 1. 8 minus 7, which is 1. Now, this is our new matrix. What are we showing here? We agreed that every cell represents a pixel, right? And the number inside the cell is a pixel intensity, right? So if I have two frames, frame 1 and frame 2, okay, of the same video, and I do the subtraction between each frames, okay, if there is no movement, okay, the matrix is going to be 0, okay. So assuming that frame 2 was exactly like frame 1, then we're going to have a matrix that will look something like this. If frame 2 was exactly like frame 1, the matrix is going to be like this. Then get 0 here because it's the same. 0, 0, 0, 0, 0, 0, 0, 0. Okay, and this is going to be a black image. Okay, it's going to be a black image because all the entries are 0. Instead, that the colors vary from 0 to 225. Sorry, 0 to 255, where 0 is black and 255 is white, and in between that is a shade of white and what black. Okay, so if frame 1 and frame 2 are the same, then when you find the difference, you get the matrix is 0, and that is black. Well, it means that there was no movement. Okay, now in this case, the matrix is not completely black. What it means is that there was some movement, right, in some pixel cells, in some cells. So the part that are black, or the part that is showing 0, 0, are places where there were static objects. Okay, so if the objects in those places are static, then the difference between frame 1 and frame 2 is going to be 0 because nothing is changing, right? What will change will be the part that is moving. So when you have a vehicle moving, then we expect that frame 1 and frame 2, when there is a difference, the cells that had the vehicle pixels are going to change, but the cells that had, let's say, pixels of, like, say, trees and the road are going to remain the same. And as such, when you do the background subtraction, you are going to end up getting 0, right? And that's the concept of the background subtraction. Okay, so we move on to our code and continue from there. Okay, let me start sharing this. Share and share my screen. Share screen. Okay, share. Okay, back to our code. Okay, so there are different um, background subtraction algorithm OpenCV that you can use, or you can write your own background, just subtracting the two frames, initial and formal, if you will, to get a background subtraction. So we'll get the background image, okay, the background subtraction. So I'll say full background is equal to CV2